The Loch Lomond Stadial was a period of time during the last ice age which occurred arguably between 11,000 to 12,000 years ago in the Younger. During this period, many glacial landforms were created and/or altered due to glacial advance and retreat. This stadial was short-lived, abrupt, and stadial glacial onset occurred. However, there were interruptions through interstadial conditions, such as periods of warming and cooling. Over the last 3 decades, a large amount of research has focused on the record of late Quaternary environmental change in Scotland, including glaciation, periglaciation, sea level change, and biostratigraphy. The Loch Lomond Stadial covered the majority of the West Scottish Highlands, and its extent is still debated today. The Loch Lomond Stadial makes a suitable case study for understanding rapid climate change and likely terrestrial and cryospheric responses today. 4 study sites have been chosen to show the evidence left behind the Loch Lomond Stadial glaciations. These are Glendow, Glenroy, Rannochmore, and Glen Etive.
Due to radical temperature oscillations of 8 to 10 degrees and an increased average precipitation resulted in rapid glaciation in the Western Highlands, but limits it to the east and central coast. The high mountains surrounding Rannochmore received high volumes of snow, probably through snow fence mechanisms, leading to the ice cap accumulations in the corries and on the plateau that quickly coalesced to form a large central ice cap with interconnecting outlet glaciers. The centre of this ice cap is estimated to have been Rannochmore.
Much of the hummocky moraine present within the northern part of the Loch Lomond Readvanced ice cap, formerly situated in the northwest Scottish Highlands, may be interpreted as suites of ice front moraines deposited during active decay. These landforms can be used to reconstruct ice cap decay, which leads to important insights into the shrinking form of the ice cap and associated environmental conditions at the time.
In Glendow, there are a number of cross-valley moraines, which are created by the oscillating temperatures seen in this area during the Loch Lomond Stadial. There is evidence of glacial landforms, which resulted in a large flat river basin area. There is also evidence of ice dam lakes further up the valley, with tide lines, and also further evidence of ice dam lakes due to landslip failures, flat-top fluvial fans, which are characteristic of settled material underwater.
An ice field developed to the west of Glenroy and the Great Glen during the Loch Lomond Stadial. This left behind many different glacial landforms. At some point, glaciers flowed eastwards along the glens from the ice field in the Western Highlands. Ice blocked the entrance to Glen Gloy, whilst another extended to block Glenroy. At this point, it potentially met a glacier that had extended into a section of Glen Spean. The blocking of Glen Spean led to an ice-dammed lake with a surface level of 260 metres, which can be seen in Diagram A. Diagram B suggests that a glacier advanced up the lower Glenroy. It cut off a lake in this valley, and the rising water eventually found its way across a pass at 325 metres. Diagram C shows that a further advance of the glacier up Glenroy resulted in a blocking of this exit water, and the lake rose to 350 metres to drain across the low ground at the head of the Roy and Spey glens. The parallel lines at Glenroy represent narrow benches cut into the bedrock of the hillsides. These could have formed through a combination of intense frost weathering and wave action. The control of lake levels by the different coals allowed the lakes to persist for sufficiently long periods of time. Evidence of these lakes can also be seen in sediments found in areas of Glenroy. These sediments are mostly sandy with dropstones, which give evidence to suggest that it was ice-covered water. Due to climate changes, the glaciers damming the lakes retreated and triggered glacial outburst floods, leaving behind the deep cut gorge flowing out of Glenroy. Advance and retreat in the Glenroy, although short-lived, left behind significant glacial evidence that we can interpret today.
In conclusion, Due to the temperature oscillations that occurred during the Loch Lomond Stadial, the glacial landforms discussed in this occur. They are all the process or resulting process of rapid temperature fluctuations, the majority of which cause glacial intrusion.